Okay, good. I think it's working. Okay, so this whole chapter that we've been doing, this is now going to be actually chapter 11.4, I believe. Chapter 11.4. In general, you guys should be starting to get used to the book, right? I mean, you know how to quickly go if you're lost on how to do something. It tells you right next to the problem which kind of example it is, right? So which example to look at. So you so if you're confused by a problem, you just go to that example. It says these are problems like examples 1 and 2. So you go to examples 1 and 2 and just look at the examples. How did they do the examples? And so it's pretty easy once you do that. Books are lifesavers. You just have to know how to use them. But there will always be times when teachers will be way over your head. And the book is, it's the thing that keeps you sane sometimes. Depending on the class and the teacher and the way they go, they do their class. So what we've been talking about, this whole chapter is about radicals, square roots, that kind of stuff, right? And why would you talk about Pythagorean Theorem?
Because
every number is squared. Look at that. A squared plus B squared equals C squared. But I don't want to know what they are. I don't want to know what the squared is. I want to know what the A is. Or the B is, and C is. How would I know what C is in this example right here?
Rectify. Yeah.
What?
Well, you'd have to find the square root of.
Right. I mean, basically, if I wanted to find out what C was, I would take the square root of C. Don't you agree with me? And I'd have to take the square root of this side. Square root both sides. I wouldn't take the square root of A squared and then stop and then do plus and then take the square root of B squared. I have to take the square root of A squared plus B squared. All right, all together. Does that make sense? Right? So then I get C is equal to the square root of A squared plus B squared. Right? So yeah, we're using radicals. And so you're going to always be using radicals when you're using the Pythagorean theorem. So, okay, so let me just erase. Can I erase?
No, you cannot.
I can't erase. Okay, I won't erase. Okay, so what we have to look at is what is a Pythagorean theorem talking about?
The triangle.
Okay, what kind of a triangle?
Right angle.
Does it have to be a right angle for Pythagorean to work?
No.
Does it have to be a right triangle?
Yeah, it does, doesn't it? Because it has to have that side.
Well, it doesn't have to be a right triangle for it to work. You just have to have the thing that goes in. So, like, if you have
Right, but then when you do that thing, I'm guessing you're talking about a perpendicular line, right?
Yeah. Well,
perpendicular means right triangle, right?
Yeah.
So you're creating a right triangle.
Yeah,
The only time Pythagorean theorem works is when you have a right triangle. Okay? There are other ways to do triangles that are not right triangles, right? But this is specifically for a right triangle. And so you will use this on a right triangle, or you'll use this if you have 3 numbers, 3 lengths of sides, and they ask you, is this a right triangle? And so you can plug those into this Pythagorean theorem and see if you get a true answer. And you'll see. We're going to do some of these. So the first thing is we've got a right triangle. So we'll do a right triangle like this. Boom. And a right triangle always has that little square, that little box right there in the corner to show you that it's a right triangle, right? What are these different sides called? Does anybody remember? The different sides. Like, what's the long side called? Hypotenuse. So the long side is the hypotenuse. Hypotenuse. This is always the long side. Why would it be always the long side?
It's the side that's across from the
It's the side across from the 90-degree angle, right? And notice in a right triangle, your biggest angle is the 90-degree angle. Always, right? Always. There's no way that these angles are going to be bigger than this angle, or even equal to. You can't have this be 90 degrees as well. there's no way you'd get a triangle. If you had two 90 degrees, right? It wouldn't work. You wouldn't have a triangle, right?
Like some weird.
So that wouldn't work.
What if the line's like curved?
Who said that?
Sal,
Get out of here. Okay, so the hypotenuse is always the longest side because the longest angle, the side that's opposite the biggest angle is the longest side. It's the biggest side. Biggest angle, biggest side. Opposite each other, always. In every triangle. The smallest angle, the side opposite the smallest angle, is the smallest side. Right? Always. Angles opposite and sides opposite each other correlate to each other.
But so on your triangle that you drew,
Yeah, which is a nice triangle.
very
Really nice.
beautiful.
Yeah. Okay, go ahead.
Which one is the smallest angle? Because that's the smallest size.
So
that means
this would be my smallest angle right here, right? That is my smallest side.
Alright.
This is my next smallest angle, and that is my next smallest side.
Right.
Or next biggest side, however you want to say it, right? But my biggest angle is here, my biggest side is there, right? Okay, so that's the hypotenuse. What are these called? Anybody remember?
legs.
Yes, they're called legs. How did you know? How did you know? That's amazing. They're called legs, right? They're called legs. These are legs. Brilliant, Nathan. And so now, what's your A and your B and your C?
Oh, legs.
So Indu.
Well, A and B are the legs. It doesn't really matter which one's which. And then the hypotenuse is C.
All right. So hypotenuse is always C. The legs are A and B, and it doesn't matter which one is A. You could make this one A and this one B, or this one A and this one B. Doesn't matter. Okay. How do you know they're legs? They're attached to the 90-degree angle.
Yes.
They touch the 90-degree angle, right? Okay. All right. So that's it. So now let's go for our first problem. Example: find the unknown length for the triangle shown. We have A, B, okay, A, 6, and 7. Okay, so here's a triangle. Let me erase this stuff so we have a little simpler. So we have, this is A, this is B, and this is C, right? And I said, it was, what was it again? Where is it? A, and then B is 6 and C is 7. B is 6, C is 7. So what would I do? I'm trying to find the length of my A. I know my length of B is 6, and I know my length of C is 7. What would I do?
Didn't we do this last year?
Yeah.
Probably. What would I do?
So you set it up so that you write A squared plus B squared equals C squared, but then you plug in the numbers, the letters, the variables with whatever numbers that you have.
Okay, so I'm just going to plug them in. A, I don't know what it is, right? So I'm going to write A squared. Plus B squared is actually 6 squared. 6 squared equals C squared, 7 squared.
Oh, I know where this is going.
Right? Okay, suddenly A squared plus 36 is equal to,
49.
thank you, 49. Now what would I do?
Square root it. No, subtract.
That would be a nightmare. Who said that?
Not me.
You don't want to square root it yet, right? Because then look, oh my God, what's the square root of A squared plus 36?
A
Right?
plus.
Don't make me do that in front of the video, right? I can't do that. So subtract 36, right? So we got A squared is equal to, let me think, there's a 3 there and there's a 1 there. Am I right? 13. Oh, shoot, but we need to know A.
It's the square root of 13.
All right. We can square root both sides. So A is equal to the square root of 13.
Well, that's easy.
Hey,
that's
we get a calculate later and
So yeah, if you wanted to, you could get out your handy dandy calculator.
It doesn't have to be handy
That
dandy.
is, and I don't think I brought it.
Yes, if it's not handy dandy, always. I'm not spending it.
That's it.
Why is everything in different places?
They're in the red bucket. They're in the red bucket.
That says playing cards.
There's
Whoa.
tons of things in here.
They changed it.
That's weird.
All right. Well, anyways, we don't have a calculator. So, does anybody have a calculator?
I do. I have mine's dinosaur.
Someone just
I know might not be might not be handy.
So go ahead and do it. Square root of 13. Or 13 squared. I mean square root. 13 square root.
3.6.
3.6. Okay, so we know A is 3.6 B when B is 6 and when C is 7. That's awesome. Alright, so that was pretty straightforward and pretty easy. Can I erase?
Yep.
Could we just leave it square root of 13? Or would you prefer?
Yeah, you could just leave it unless somebody really wanted to know. I mean, if you really wanted to know what that was, I mean, who knows what square root of 13 is really? You know, it's
I do.
Yeah.
You know that 3 times 3 is 9 and 4 times 4 is 16, so it's got to be between 3 and 4, right? It's gonna be 3 point something. So if you need to know exactly, you get out your calculator, right? But I'm fine with leaving it as the square root of 13 for the purposes here, because I figure you should all know how to use it, right? The calculator. You can all do that, right? You know how to do that. So I don't care. Okay. Here's the next problem. Next problem. This gets more fun here. Okay, a right triangle. All right. Actually, let me erase this because I want to have the space to do this.
What did go wrong?
Okay, a right triangle. So you have to write this down. So write this down. A right triangle, and that's my abbreviation for triangle, okay? Just a triangle. A right triangle has one leg that is 2 inches longer than the other leg. Has one leg that is 2 inches longer than the other leg. The length of the hypotenuse is the square root of 10 inches. Hypotenuse is equal to the square root of 10 inches. Find the unknown lengths. Find unknown lengths.
Isn't the hypotenuse just 10?
I'm sorry?
Isn't the hypotenuse just 10?
It's
the square root of 10.
Yeah.
Right. So it's not the hypotenuse. It's hypotenuse squared would be 10.
Yeah.
Right? Yeah. So you're right. Exactly. You got the right answer. So let's draw our little triangle here. So we'll do it like this. We say.
Gary, what do you mean in unknown lengths and unknown units?
Well, let's look at it. Let's just see. Once we plug this into draw our little picture, I think it'll be really clear. So it says a right triangle has one leg that is 2 inches longer than the other. Which one is going to be the smaller leg?
The one that's going
This one? Right? So we'll make that x maybe? Right? And then what's this one?
X plus 2.
It's 2 inches longer. How would I write that?
X plus 2.
X plus 2, right? X plus 2. Okay. And it said my hypotenuse is the square root of 10. Square root of 10. Okay, so then it's saying find the unknown length. So Liam, where are the unknown lengths? This side is unknown because it's an x, right?
Yes.
And this side is unknown because it's x plus 2. So when you first look at this, it's like, how could you ever find this answer? I mean, it seems like, I remember when I first saw these, I thought, God, there's no way.
It's impossible.
But it is very easy because we just use our a squared plus b squared equals c squared. Which one are we going to make a squared? Let's make this a squared. So this is a equals x, and b is equal to that. So we'll just go ahead and write that. So we got, instead of a squared, we're going to put x squared, plus, instead of b squared, we're going to put x plus 2 in parentheses, squared, equals the square root of 10. Now, squared. Sorry. Thank you. Square root of 10 squared. Okay, and then we've got x squared plus, now how would I do this? Is that just x squared plus 4?
It's a binomial.
Would that be x squared plus 4?
No.
Why?
Because it's a
Binomial.
And you have to use
FOIL.
FOIL. Right, so we're going to write it out. We're going to do x squared plus x plus 2 times x plus 2, and then equals square root of 10 squared is 10. That makes it easy. So now we'll keep going. X squared plus, we've got x times x is x squared. Okay, 2x is the outsides, 2x is in the sides. 2x plus 2x is 4x, so plus 4x. And then plus the last, which is 4. Plus 4 equals 10. So now we can combine a few things, right? I've got two x squareds, right? Got one there and one there. If I add them together, I have two of them. 2x squareds plus 4x plus 4. It doesn't look like an x.
With 4.
Equals
the
10. Did I do that right? Yes. Okay. What's the first thing? Well, first of all, what do I have? What do I have?
A quadratic. Well, not quite. You need to subtract 10.
You almost have a quadratic trinomial.
I do have a quadratic trinomial right here, but I have that 10. And what is the rule, general rule of thumb?
It has to equal 0.
You want it to equal 0, right? So we're going to make it equal 0. We're going to subtract 10. Subtract 10. So we have 2x squared plus 4x minus 6 equals 0. All right. What's the first thing you always try with a quadratic trinomial?
Factor.
Greatest common factor, right? Remember? Always the first thing. Oh my gosh!
X has to be 1.
2 goes into both of those things, all 3 of those things. Actually, all 4. It goes into a 0 too, right? So I can just divide by 2, divide by 2, divide by 2. Now I have x squared plus 2x minus 3 is equal to 0. Now what would you do? Whenever the a in front of the x squared is just a 1, and it's a trinomial, you try to factor it, right? You immediately put your 2 sets of parentheses, right? Parenthesis, parenthesis. Can you guys see it down here?
Yes.
Oh gosh. I think our video just died. Oh no, it's still on. Ooh, shoot. Do not do this. Restart your computer. Postpone. I forgot to plug this in. Sorry guys. We're pausing for station identification. Thank you. That's Nate. That's Nate. Nate. Okay. Alright, so we got x squared plus 2x minus 3 equals 0. What is it? We got 2. We've got we got these things equals 0, so we got x, and we've got factors of negative 3 with add to 2.
3 and 1, negative 1, 3.
Negative 1 and positive 3. Yes. Negative 1 and positive 3. Therefore, x is either equal to 1 or negative 3.
And it's probably 1 because that would be
You guys
weird.
have a negative leg.
Probably not a negative 3, right?
That would be weird.
Probably a 1.
That's totally possible.
So what are our sides? So our sides are x is 1, 1 and 1 plus 2, which is 3. There we go. So we did it really easily. So they're cool because we're doing everything we've learned in the last 3 chapters of this book, basically. You know, we're starting off with just the Pythagorean Theorem, which is just simply radicals, and then suddenly we've got a trinomial. We had to get it in the right fashion, set it equal to 0. We had to divide by greatest common factor and then factor. Just like everything we've learned is in this problem, which is really cool. It's really kind of fun. Can I erase? Yes? No?
Absolutely no.
I don't think I need to do those because we've covered that. Converse. Okay, the converse of the Pythagorean Theorem. Can I erase now? I'm going to erase the top part. I'm going to erase the bottom part now. Okay, there is something called the converse. I don't know the actual definition of converse, the dictionary definition, but converse is sort of like the opposite of. Would you agree with that? Sort of. It's not really the opposite of. It's like it's like looking at it backwards. So we've got the Pythagorean theorem that says if it's a right triangle, then you take the square of both sides, the sum of the square of both sides, and that equals the square of the third side. Okay, that's what the Pythagorean theorem says. If it's a right triangle, this is true. The converse is just the reverse of that. The converse says if a squared plus b squared does in fact equal c squared, then it is a right triangle. Does that make sense? Right? Does it make sense? Pretty straightforward. But that's the converse. It's like going backwards. Instead of saying a squared plus b squared equals c squared, I mean, if it's a right triangle, then you can do this. You're saying if a squared plus b squared equals c squared, then it is a right triangle.
It's like tell us if it's right triangle.
What?
So there might be problems with like tell us if it's right triangle.
Right. So example. So like an example would be like tell me if this is a right triangle. Let's say we have three sides. We have three sides. Is this a right triangle? And here's the three sides. I give you 8, 15, and 17. 8, 15, and 17. How do I know which one is which?
The hypotenuse is the longest
The
one.
hypotenuse is always the longest, and it doesn't matter which one is A and B here, right? It's only the hypotenuse that you have to be sure you get right. So we immediately know, well, a squared plus b squared equals c squared. I'm going to plug in 8 squared plus 15 squared equals 17 squared. So 8, okay, who has the calculator again?
8 plus.
Yeah, keep it out. So 8 times 8 is 64. I can do that one. Plus 15 times 15 is?
225.
Thank you. Is that right?
Yeah.
Okay, great. And then 7 times 17, Sal, is? Yeah, okay, quick. All right, who has the calculator? 17 times 17.
289.
Say it again.
289.
289. Okay, now we're going to add 64 to 225. Let's see, that's 289. Oh, 289 equals 289. Is that true?
Yes.
If it is true, yes. That means this is a right triangle. Does that make sense? Because this is saying the sum of the squares of the two sides equals the square of the hypotenuse. Therefore, it is a right triangle. If it came out to 289 is equal to 364, would that be true or false? False. If it's false, then it means it's not a right triangle.
Right.
It's still a triangle, just not a right
It's
triangle.
a wrong triangle.
It's a wrong triangle, right? Exactly. All right, so we'll try one more. How about 5, 8, and 9? Okay, here we go. 5, 8, 9. That's my hypotenuse. So we've got 5 squared plus 8 squared is equal to 9 squared. 5 squared is 25 plus 8 squared is 64 equals 81, right?
That's
All right,
true.
25 plus 64 is 89. So 89 equals 81. Is that true?
Slow down. Yes. Sending you back to 3rd grade.
It came back a day too early, Clayton. Okay. All right, so 89 is equal to 81. No!
Yes.
It's still a triangle, but it's a wrong triangle, like they were saying. It's not a right triangle, okay? So it's pretty straightforward. Pretty straightforward. And then there's word problems and stuff, but I don't think word problems, you just always look for, you know, you look for your triangles and where they are and what you're going to do. It's pretty straightforward. The homework tonight that at least for my group, Nate may change that. Actually, I want to write that down. So homework tonight is page. So this is 8th grade.
I am the child of Urk.
So your homework is pages 740 to 741, numbers 6 through 8, comma, 12 through 15, comma, 17 through 20, comma, 23, 24, and 29, and 34. They're not that hard. They won't take you that long to do. Use a calculator. Can you see that?
It's too many.
No, it isn't.
Yes.
No, it isn't.
Can we
Just
start
move that a little bit so it can be seen on the screen.
It is.
Oh, I didn't get. Let me go further.
Are you sure? I thought it was
There we go.
marathon.
So it's pages 740 to 741, 6 through 8, 12 through 15, 17 through 20, 23, 24, 29, and 34. Some of those are word problems, just for you to practice those things. Do you want to split now?
Yeah.
All right, so let's have the conceptual group head with Nate.